Hello, in this video I'm going to now apply our strategy for deriving biconditionals and give an example of how it works now that we've said what it is. And let's quickly just remind ourselves of what it is. So when we when our show line is a biconditional, then the idea is to show each conditional, stick them together with CB, and we have a direct derivation. And we can use this show command to tell the program to write out these show lines for us. So that's what we're going to do. So we'll say show conclusion as we always do. Let's have it in caps just for fun. Okay, so there's our conclusion. We don't need to make an assumption. We're just going to go ahead and try to show the two pieces and then stick them together. So we'll say show conditional, and let's do if R then P first. As it turns out, that's going to be easier. It doesn't matter, but I think for purposes of demonstration, we're going to do this one first. So we're trying to show a conditional, so we're going to say assume CD. Now at this point, we have a couple of options. We should always check, can we box and cancel right away? We can't because we don't have P, but we want to get P because that would let us box and cancel with CD. We could say show cons, but as it turns out, that's not necessary, so we're going to skip this step in this case. We're going to bring in our first premise and our second premise, and we could bring in our third premise, but we don't need to. But if we look at premises 1 and 2, we can say, oh, look, 3, 4 modus ponens, good. Oh, 5, 6 modus ponens. Hey, we got to P, that's the consequent. We're done. Well, we're done with the first half. So we've shown one of the two conditionals. We've shown one of the two conditionals that makes up this biconditional that is what we're trying to get. Great. So now let's go ahead and show the other conditional. If P then R. So we'll say assume CD, it gives us P. And if we pop in our different things, we say, oh well, P, we can't do anything with P in this. We can't do anything with P in that. We can't go backwards. We need not P for modus tollens. So it's not going to work with either of those two. Maybe we could get, what about this? Well, this is the negation of a conjunction. So if we could get the conjunction, if we could get P and not R, then we would have what we need for ID. And we do have P there, so that's suggestive that, well, we at least have one half of this. We have this half. If we could end up getting not R, then we'd be in a good situation to do ID. But right now we don't have not R, so let's just actually get rid of all of this stuff because we can't actually do anything. And let's just say show cons. And say assume, because, right, we're trying to show a conditional. Show cons is always a good idea. Well, it's always never hurts, and sometimes is necessary. So we'll say assume ID, giving us not R. And we can go ahead and repeat 10 just so that we have it with the material we're working with. So right now, really, these are the only two lines we have. And then we can bring in our premises again and say, well, you know, what are any of the premises going to be helpful? And we might notice, oh, wait a minute, there's that negation of a conjunction, negation of P and not R. I can make P and not R now because I have P and I also have not R. So let's do that. We'll say 13, 12 adjoin, build P and not R, and we don't actually need these. All we need is this premise. And so now we have a contradiction. So we'll say 14, 15 ID. That gives us a contradiction for letting us cancel this line 11. Now, why did we do line 11? Well, because line 11 is the consequent of the previous show line, and that means we can apply CD to line 11 to cancel the previous show line. Okay, well now we have these, done these two subderivations, which is all we need, because now we have the two conditionals that make up line 1. So let's go ahead and apply CB to them, and choose P if and only if R, and that's a direct derivation. And there we go. So the overall structure is we show one conditional, and then we show the other conditional, and then we stick them together, and we box and cancel with DD. And how we show each of these conditionals, well, that depends upon what's going on with those conditionals and the rest of what we have in our derivation. So to show if R then P, well, we get R, and then we bring in our two premises, and we can, allowing us to use modus ponens to get to P, which is the consequent of the conditional we're trying to show, so we apply CD to that, boxing and canceling line 2. I'm going to go ahead and close this up, so if you want to look at that again, you should pause the video. Now, how about if P then R? Well, we again said assume CD, but in this case, we couldn't do anything with the premises in P by itself. So I said, good, let's show the consequent of line 9, which using show cons. The idea being that once we get R, we can apply CD to cancel this. And hey, it lets us make this indirect assumption. So then we have, at that point, P, and we have not R, and that lets us build P and not R to contradict the third premise, which is what we need for ID, letting us box and cancel R. And once we box and cancel R, well, R is the consequent of line 9, and so we can then, once we box and canceled R, we can use CD with R to box and cancel line 9. Okay, I'll pop that open if you just want to go ahead and pause the video now. But the overall structure is show the two conditionals, maybe just with assume CD in the premises, or maybe with assume CD and then show consequent and then some of the premises, depending upon what the situation is, but we're able to get to P if and only if R. And so that's an example of how we use our show conditional subderivations to get to the to build the conclusion in order to apply direct derivation. So that's how our new strategy works.